Let's explore the architecture of Kafka, a powerful distributed streaming platform. This presentation provides a deep dive into the core components and principles that make Kafka a cornerstone for modern data pipelines. Apache Kafka is a distributed streaming platform designed for building real-time data pipelines and streaming applications. It is essentially a publish-subscribe messaging system that is fault-tolerant and scalable. Kafka is known for its high throughput and low latency, making it suitable for handling trillions of events per day. Its core purpose involves real-time analytics, facilitating seamless data integration, and enabling efficient event streaming. Kafka has four core components. First, producers, which are applications that publish messages to Kafka topics. Second, topics, which are categories where messages are organized and stored. Third, partitions, which represent an ordered sequence of messages within topics. And finally, consumers, which are applications that read messages from topics. Producers are responsible for sending messages to Kafka topics. They can automatically choose a partition or manually specify one. Producers handle the serialization of data into a format suitable for Kafka, offer delivery guarantees to ensure messages are not lost, and support batching for efficiency, allowing multiple messages to be sent in a single request. Here's an example of how to create a producer and send a message using the Kafka Python library. First, import Kafka Producer from Kafka. Then, create a producer instance, specifying the bootstrap servers. Finally, send a message to a topic, such as user events with a value like user clicked, and remember to flush the producer to ensure the message is sent. Topics are logical groupings of messages within Kafka, serving as named feeds of data that can be consumed by multiple producers and multiple consumers. Topics offer configurable retention policies, allowing you to specify how long messages should be stored. Partitions are ordered sequences of messages within a topic, forming an immutable message log. They enable parallel processing and are distributed across Kafka brokers for scalability and fault tolerance. For example, a topic named user events might contain messages related to logins, logouts, and clicks. These messages are then divided into partitions, such as partition 0 containing messages M1, M2, and M3, and partition 1 containing messages M4, M5, and M6. Consumers are applications that read messages from Kafka topics. Each consumer tracks an offset for each partition, indicating the last read message. Consumers can form consumer groups, allowing multiple consumers to work together to read from a topic. Kafka handles load balancing within a consumer group, distributing partitions among consumers. Consumers use a pull-based model where they request messages from Kafka. Here's an example of how to create a consumer and read messages using the Kafka Python library. First, import Kafka Consumer from Kafka. Then create a consumer instance, specifying the topic, group ID, and bootstrap servers. Finally, iterate through the consumer to receive messages and print their values. Kafka achieves high throughput through several key techniques. It uses sequential disk input-output operations. It also utilizes zero-copy data transfer to efficiently move data between storage and network. Kafka employs message batching and compression to reduce overhead, asynchronous processing to avoid blocking operations, and efficient serialization formats to minimize data size. These techniques result in several performance benefits, including the ability to handle millions of messages per second, low latency data delivery, horizontal scalability, memory-efficient processing, and network bandwidth optimization. In summary, the Kafka architecture follows a simple flow. Producers send messages to topics and partitions, from which consumers then read. Kafka offers scalability through partitions and distributed brokers, as well as high performance via batching, compression, and zero copy. Ultimately, Kafka enables real-time data streaming at massive scale, making it an ideal solution for modern data-intensive applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.